Hello friends, welcome back to my YouTube channel for an outstanding chemistry class. Today we'll be looking at a very important topic in chemistry called balancing of chemical equation. Stay tuned, let's dive in together. Yeah, look at the topic called balancing of chemical equation. What's a balancing of chemical equation? Chemical equation, by definition, is a shorthand expression for a chemical change or a reaction which shows, among other things, the arrangement of atoms that are involved in any chemical reaction. Or you can say a chemical equation are brief representation of a chemical reaction using only formulae and symbol. Look at the keywords: shorthand. Another keywords: representation. Keywords: formulae and symbols. Yeah, having looked at the definition of a chemical equation, there are common symbols that are very important in chemical equation. Number one is this arrow. Look at the way arrow is. The meaning is yield or produce. It's pointing or pointed towards what? Towards the product. We look at what a product is in a chemical equation. Look at the two arrowhead. Okay, one arrow going forward and that one coming backward. It's called reversible reaction, or in equilibrium, we call it equilibrium between the reactant and the product. Look at another symbol. It's called gas evolved. It's written after a substance, after a chemical reaction. Look at another S inside a bracket, means solid. Okay, written after as a subscript after a substance. L in a bracket means liquid. It's written as a subscript also after a substance. Another one is G, is meaning gas, written as a subscript after a substance. This symbol you're looking at it means heat, while AQ is meaning what? Aqueous solution, substance dissolved in water. Why this sign is plus, or add to, or reacting with in a chemical reaction. Yeah, after the symbols of chemical equations, there are certain things to note. Number one, a chemical equation consists of what is called reactants and products, with other symbolic terms discussed. Okay, what is a reactant? These are the substances that enter into a chemical change or a reaction. According to IGCSE, a reactant are substances being what? Reacted with. What is a product? Products. These are the substances produced by a reaction, or the products are the substances being what? Being produced. In balancing chemical equation, things to note: number one, know the reacting substances and the product form. Very key. Know the chemical formula for all the substances involved in a chemical reaction. Right in front of the formula, the coefficient that will balance the equation. We'll just say in the example below. Common gases such as oxygen, hydrogen, chlorine, and nitrogen. Okay, in free state, they are diatomic. For instance, there's oxygen is called O2, it's written as O2, hydrogen is written as H2, chlorine is written as what? Cl2, and nitrogen is written as what? N2. Right. Other elements in the free state, such as sodium, potassium, copper, and iron, are represented by their symbol. They are not in the atomic state. So sodium is represented as Na, potassium is represented as K, copper is Cu, and iron is what? Fe. Okay, having learned all the rules, all you need to know on how to balance a chemical equation, let's look at one or two examples. Okay, example one. Let's look at example one. Let's look at the reaction between hydrogen gas and oxygen gas to form what? To form water. Okay. So in balancing chemical equation, remember, you must know that the reactants are written at the left hand side of the reaction. Okay, and they are separated by an arrowhead called yield in our symbol, remember, while the product are written at the right hand side. And this one must obey what? Laws of mass, conservation of mass, or conservation of matter, which says that energy can neither be what? Created nor destroyed, but they can be transformed from one form to the other. So let's look at how to balance this chemical equation on the board. So let's use this method. Okay, in balancing chemical equation now, let's look at the left hand side. What are the elements involved in the left hand side? We have hydrogen, product 2 hydrogen, we have oxygen, and we have what? Oxygen. Alright, now looking at this, how many hydrogen do we have before the arrow? We have 2. After the arrow, after the yield, we have 2. These elements are balanced. How many oxygen? 2. 2 oxygen. How many oxygen here? 1 oxygen. It shows that this reaction does not obey the law of conservation of matter. So we have to balance it by making use of the coefficient. The coefficient of hydrogen is 1, while the coefficient of oxygen is 1. The coefficient of water is also 1. So let's check it out. So I need to balance up oxygen. I have 2 oxygen at the reactant side and 1 oxygen at the product side. So I can do that by making use of my numerics. Let me put 2 here. Putting 2 here shows that I have 2 molecules of water. Okay, which shows now I have what? 4 hydrogen, 2 times 2 making 4, 2 times 1 making 2. So my oxygen here is balanced at the product side. Let's come back to the reactant. How many hydrogen do I have at the product? 4. How many hydrogen at the reactant? Only 2. Alright, so I'm going to what? I'm going to balance my reactant. Okay, I'm going to put 2 here. Putting 2 here, 2 multiplied by 2, I have what? I have 2. So I have 4 right now. 2 times 2 making 4. That means my hydrogen are balanced. But let's look at my oxygen now. My oxygen is 2. So check the equation from the beginning again. At the reactant, you have 2 times 2, hydrogen is 4. Hydrogen is 4 like the product. At the reactant, oxygen is 2 and oxygen is also 2. This reaction is chemically balanced. It does obey the law of conservation of matter. Alright, that's example 1. Okay, let's quickly dive into example 2. Example 2. So let's look at this chemical equation. KClO3, the decomposition of potassium triiosochlorate 5. Okay, to yield potassium chloride plus oxygen gas. This is solid. Now looking at this reaction, you will see that this reaction is not balanced. It does not obey the law of what? Conservation of matter. So let's look at it. What are the elements involved? Here I have potassium, here I have chlorine, and here I have oxygen. The same thing here, potassium, chlorine, and oxygen. Here, how many potassium do I have here? 1. Here also 1. Chlorine here is 1. Chlorine here is 1. Oxygen here is 3. Oxygen here is 2. Now, when you look at it, this equation is not balanced. It's not balanced. So my job here is to balance the chemical equation by working on the coefficients. 1 coefficient, 1 coefficient, 2 coefficient. Remember, any coefficient you put in front of a chemical equation affects all the elements inside that chemical equation. Okay, let's look at it. So if I have 3 oxygen, I have 2 oxygen. So how will I make this? How will I balance this chemical equation? Okay, let's look at it. I cannot put 1. Let me start by putting 2 two numerics. So if I put 2 molecules of KClO3, it has affected all this reaction. For now, we have 2 chlorine. Let's change it. 2 potassium, then 2 chlorine. Then how many oxygen? 2 times 3, making what? 6 oxygen. Okay. Now, looking at the products, my potassium is going to be affected. So I'm going to put 2 for potassium. So I have 2 what? Potassium. I have 2 what? Chlorine. Now my oxygen now is not balanced. My oxygen is still 2. At the reactant, I have 6 what? 6 oxygen. So I'm going to just put 3 here. Because 2 times 3 will give me what? Will give me 6. Okay. Now I have to change this one to what? To 6. So let's check the equation properly, whether it has obeyed the law of conservation of matter. Okay. 2 potassium, 2 potassium. Okay. 2 chlorine, 2 chlorine. 6 oxygen and 6 oxygen. So this chemical reaction is already balanced and it has obeyed the law of conservation of matter. Okay, we have seen a transformation from this to this, but nothing is destroyed. Nothing is destroyed. If you have any question, put it on the comments below. Then 3. Okay, example 3. Example 3. Okay, a combustion reaction of an organic compound called methane. Methane is CH4, okay, plus 2 oxygen, producing H2O gas plus CO2 gas. Now, looking at this equation, let's look at this carbon. Equals to how many? 1. Another carbon, 1. Okay, these are the elements involved. Hydrogen, 4. Hydrogen, 2. Oxygen, 2. Another oxygen. Now look at the oxygen here. The oxygen here now we have 1 in the water and another 2 oxygen from what? From carbon 4 oxide. Total of what? 3 oxygen. No, my carbons are balanced. My hydrogen and my oxygens are not balanced. So let me start to balance my hydrogen. You can see there are 4 hydrogen here and I have 2 hydrogen. So if I put 2 here, it becomes 2 molecules of water, which changes this one to 4. So my hydrogens are balanced. But putting 2 here has an effect on the oxygen, because in a molecule of water we have hydrogen and oxygen involved. So my oxygen here is changing from what? From 3 now. This one is changing to 2. 2 plus 2 giving me 4. So I have a total of 4 oxygen at the right hand side of my chemical equation with this product. So definitely I need 4 molecules of oxygen here, 4 atoms rather, not molecules, 4 atoms of oxygen in the reactant side. So I'll just put 2 here. So let me cross check my work. Carbon 1. Carbon 1 is balanced. Hydrogen 4 at the reactant, hydrogen 4 at the product, balance. Oxygen 4 at the reactant, and oxygen 4 at the product. This chemical equation has obeyed the law of conservation of matter, which is chemically balanced. So let's look at example 4. Example number 4. Example number 4. Let's look at a transcarbonate reaction, okay, between an acid. Acid, let's look at HCl, nucleic acid plus something like sodium transcarbonate 4, okay, yielding sodium chloride in aqueous form plus water in liquid form plus CO2 in gaseous form. Okay, it means carbon 4 oxide is giving off in this particular reaction. So looking at elements involved, what are the elements involved? We have hydrogen, we have chlorine, we have sodium, we have carbon, and we have oxygen. Okay, we have sodium, also chlorine here, hydrogen here. Let's look at the same. Let's do the same thing. Hydrogen, chlorine, sodium, carbon, and oxygen. So how many do we have? Here I have hydrogen 1, chlorine 1, sodium 2, carbon 1, and oxygen 3. Here I have hydrogen 2, chlorine 1, sodium 1, carbon 1, oxygen 1 plus 2, making 3. So when you look at this transcarbonate reaction with acid, it shows the equation is not chemically balanced. So let's look at how we can balance it. Hydrogen 1, hydrogen 2. Okay, can I make my hydrogen 2 here? Okay, let me put 2 here quickly. My hydrogen is already 2 here. Since my hydrogen is 2, it has affected my chlorine. So I have to change my chlorine from 1 to 2. 1 to 2. Okay, this is carbon. So we're going to add this from 1 to 2. Now, look at it now. So, if my chlorine has affected, so let me go and work on my chlorine. Okay, working on my chlorine here, I have to put 2 here. My chlorine here is 2. Okay, make my chlorine what? Balance. But you know, it has affected my sodium. Okay, sodium here is what? Is 1. While sodium here is 2. So, automatically my sodium here becomes 2. Okay, let me check my equation. You can see that it's making sense now. Look at hydrogen, let's cross check. 2, both reactant and product. Chlorine, 2, both reactant and product. Sodium, 2, both reactant and product. Carbon is 1, both reactant and product. And my oxygen is 3, my oxygen is also 3. This equation is chemically balanced. Obey the law of conservation of. Okay. Lastly, in this video, let's look at a neutralization reaction, that example 5. Before I give an assignment, that you just drop in the comments section below the answer. Example number 5. Let's look at a neutralization reaction between a strong acid and a strong base. Say for instance, we have tetraoxoxalic acid at H2SO4 plus sodium hydroxide. In the aqueous solution, they're going to use sodium sulfate plus water. Okay, so let's put out the elements involved. Hydrogen. Hydrogen, here we have 3 hydrogen. We have 3 hydrogen. Sulfur. We have 1 sulfur. We have sodium. No, oxygen. Let's look at oxygen. Oxygen is 5. And let's look at sodium. Sodium is 1. So let's go to the product. Hydrogen here is 2. My sulfur here is also 1. My oxygen here was my oxygen 4 plus 1, 5 oxygen. And my sodium here is 2. That's 2. Okay, let's quickly see. What will I start with? Where will I start? I can start from hydrogen. Here I have my hydrogen here is total of 3. My hydrogen here is total of what? Of 2. Okay, let me balance my hydrogen. Let me put 2 here. If I put here 2, hydrogen is coming from total of 6. While 2 hydrogen is coming from sodium hydroxide. So my hydrogen is what? Total of 4. So let me go to the product and work on my hydrogen. Yes, I can just put 2 here. 2 times 2 making 4. So my hydrogens are balanced. Let's go and check my sulfur. My sulfur is coming from H2SO4. I have 1. So coming from sodium sulfate. I also have 1. Sulfur is balanced. Let me check my oxygen. 4 plus 2. Okay, my oxygen is changing now to 6. Okay, let me check my oxygen. Also, the product 4 plus 2. Making what? Making 6. I hope you are following. Please do it. Follow. Sodium is the last element involved here. Let's check the sodium. Sodium is coming from here. We have 2 sodium now. Then we have 2 sodium. Okay, this equation is chemically what? Balanced. Okay, lastly on this video, let me leave you with this assignment. Okay, if you have not subscribed, I don't know what you are waiting for. Okay, make sure you subscribe. Okay, make sure you like this video. Okay, make sure you comment. Very, very important. And your notification button is very important to get more videos. Because I'll be posting this periodically. Okay, let's look at this assignment. Let's look at a reaction, a permanganate reaction of KMNO4, KMNO4, okay, plus 2000, we see that's acidified KMNO4, acidified KMNO4, going through hydrogen sulfide, which we produce K2SO4 plus MnSO4 plus water and plus sulfur. Okay, this is aqueous. This is aqueous. This is also aqueous. This is a gas. This is aqueous. This is also aqueous. This is solid, and this is liquid. Okay, if you can balance this chemical reaction, okay, let me see you. Okay, just drop it in the comment section below if you have followed. If you are balanced, see you in my next video. Thank you. Remember to subscribe, comment, like, and share this video. Make sure you share this video. Notification button is very important